In today's session, let us understand about grounding and types of grounding. First of all, let us understand what is grounding. The term grounding means it's a process of connecting the neutral point of a power system or the non-current part of the electrical appliance to the general mass of the earth. So what happens whenever there is a fault? So immediately all the electrical energy is discharged through the ground to the earth surface. Now by doing so, what will happen? It will protect the equipment and also the human beings. So this is the meaning of ground. Now let us understand the difference between grounded and ungrounded system. In older days, generally systems with isolated or ungrounded neutral were being used and they were common in those days. Now whenever we say in the case of three-phase overhead transmission systems, the undergrounded neutral holds the promise of continuity of the supply. Now whenever in the event of phase to ground fault, even if one of the lines develops an earth fault, it is very much unlikely that the other two lines are affected to the appreciable extent. Now we can say ungrounded systems may provide greater continuity of operation whenever there occurs a ground fault, but the secondary fault is most likely to occur and it becomes more catastrophic than the ground system fault. So whenever ungrounded systems are used in the facility, what will happen? The maintenance person should receive training and exactly how to detect and troubleshoot the first ground on an ungrounded system. So generally electrical systems that can be operated both on grounded or ungrounded way. So depending on the which condition they are used or where they are used and what type of circuit they are using for the protection scheme and what type of enclosures have been used and what type of dangerous voltages they are going to face, and we have to train the personnel to how to be safe from the electrical shock. So generally grounded means the connection in ground between the service panel and the earth that has been made. So ungrounded electrical systems are nothing but they are used where the designer does not want the overcurrent protection device and they will clear in the event of a ground fault. Now there are certain advantages of grounding. Always there is an advantage. What are those advantages? Generally the safety of the personnel and the equipment. Whenever there is an adverse effect of lightning or anything occurs, then definitely that can be protected. Then the equipment can be protected against the transmission line, against voltage stresses which might occur in the transmission, and it provides stable neutral point. And if in case of the earth fault, so magnitude of the fault current can be limited so that the operation of the relaying equipment is facilitated, and obviously when you provide the safety, the reliability will be improved and economy and performance of the system can also be improved. Now when it comes to types of grounding, let us understand different types of grounding here. So in the first one, let us understand about solid grounding. When we say solid grounding, when we observe a star connection with three phases R, Y, P, and in a star connection there is a neutral point and the same neutral point is grounded. So generally in solid grounding what will happen? So the neutral of the power system is connected to earth through a thick solid conductor having practically no resistance. There should be no resistance in that wire. So in this type of system generally it uses a large plate or pipe and they are made up of a copper as an electrode to which the neutral will be connected. Generally the electrode will be buried deep inside the ground and the pit is filled with the salt and the mix of charcoal and a small amount of water is also watered. So whenever, so as to increase the conductivity. So why? Because since the resistance offered with this electrode and the connecting path is very much small, so large current can easily flow into the ground in the event of fault. So there are certain advantages, and this is the simple method. What are the advantages here is, so arcing ground is prevented here, since the effect of the capacitive currents get multiplied whenever there is a fault current. Also it permits the use of discriminating protective gears, and there is a disadvantage that when larger capacity circuit breakers and associated relaying equipments are required, in this case because of the simple earthing system, then large fault currents may cause unwanted interference here, because with it may interfere with the neighboring communication circuits also. Next we have resistance grounding. Here entire circuit and everything remains to be same, so you can observe here, but the wire which are used for the grounding from the neutral is resistance wire. So what happens in the system, as we discussed in the previous case, from the neutral wire it is earthed, but we are using a resistance, we can say RS. What is the use of this resistance is, so it can limit the fault current to a safer value. So that is the use of this. Next we have resonant grounding. In case of resonant grounding, you can observe here we are using an Peterson coil. So this is an improvement when we compare in overall grounding system. So this resonant earthing system eliminates completely the possibility of any arcing, so by limiting the fault current to extremely lower values. Even here you will be able to limit it to 0. Here the basic principle what they used is, now imagine if a coil of inductance of a suitable value and which is connected in parallel with respect to capacitance of the system, then the resonance phenomena occurs at that particular system frequency, and because of that the fault current reduces to a minimum value. So this is how it will work. So these are the various grounding systems. Hope you understood. Thank you.